John Louis N. Livaras,
Glenville John B. Kitani,
Eugenio M. Timpi,
Rohinin E. Rillama, Lurgy P. Ortula, Bilinia B. Lumpa,
Jane Eliza B. Michon,
Catherine O. Villamor,
Maria E.G. E. Tinapon,
Grisha R. De La Cruz,
Rian L. Parado.
Now, we'll tackle is all about the Newton's law of motion. Today, we'll learn about how force and motion is related. What are Newton's three laws of motion? What did Isaac Newton observe? The relationship between force and motions. An object free to move will move up upon by force. First, a push, pull, or twist upon an object. The second is often a result of an interactions between two objects.
The three types of motion. The first one, inertia. Inertia is an object resistant to changing its motion. The second one, velocity. Velocity, the speed and direction of an object in motion. The last one, acceleration, the change in an object's velocity.
Isaac Newton's ideas, apart from gravity, Newton also explained how the balance of forces affect of an object's movement. When the forces are balanced, the object will remain in its state of motion, either erased or constant motion. But when all the forces are unbalanced, the object will either speed up, slow down, or change its direction.
But what about other factors such as friction and air resistance? He further developed these ideas into what we know now as laws of motion.
Experiment break. Together with a seatmate, find different ways of moving your chairs in a different directions without standing up. What happens when the chair is pushed by the other person? What do you observe when you push each other's at the same time?
The example of low inertia. The soccer ball will remain resisting on the grass until a force acts on it. While it's kicked, the soccer ball's inertia will keep it going because the ball resists changing its motion. If the ball doesn't hit anything, the force of gravity and friction will eventually stop the ball.
What does the ball resist changing its motion? Correct, because of inertia. What does the gravity and frictions eventually stop the ball? Correct, because on Earth, the gravity and frictions are unbalanced because the force are often change an objects of motion.
There's another definition of inertia. First, the resistance of physical object in any change in its state of motion. Second, it's proportional to the mass of the object. Third, big masses resist changing their motion more than the small masses. Three types of inertia. Inertia of rest. The inability of a body change itself its state of rest. Inertia of motion. The inability of body to change by itself state of uniform motion. The inertia of direction. The inability of a body to change by itself its direction of motion.
Weight F. Ball of Earth, gravity of an object. Obtained by the product of mass of an object, m, and the acceleration due to gravity, g equal 9.8 meter per squared second.
Friction, the force that resists sliding motion. Two conditions in order to have friction between two objects. First, object must have surface in the contact. The second, object must have sliding along the surface of contact, or at least there must be an external force that's trying to slide. Newton's second law of motion, the law of acceleration, states that acceleration of an object with constant mass is proportional to the net force action of it, and it is the same direction of the net force. The law of acceleration. Example, the car accelerates forward since the force due to its engine is greater than the friction on the road. F equal ma, wherein F equal net force and m equals mass.
1 Newton equal 1 kilogram meter per square second. 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second per second. Weight versus mass weight, the force of gravity acting on an object mass. How much matter makes up an object? A person will have the same mass no matter where in the universe it is measured. However, a person's weight will be different depending on the force of gravity where it is being measured.
An object of a mass 200 kg is observed to accelerate at the rate of 4 meter per square second. Calculate the force required to produce this acceleration. M equals 300 kg, F equal blank. A equal mass per meter per square second. F equal MA, F minus 300 kg, F meter per square second, F minus 1,200 kg meter per second equal 1,200 M.
Newton's third law of motion, the law of action and reaction. For every action, there is an equal and opposite reaction.
The law of action and reaction. First, action-reaction pairs. Second, equal in magnitude. Third, opposite in direction. Fourth, act on two different objects.
The law of action and reaction. Example. First, a kayaker moves forward by exerting an action force on the water with a paddle. Second, the water pushes back on the paddle with an equal reaction force that propels the kayak forward.
These are the two questions. Are two forces with an equal magnitude and opposite direction action-reaction pairs? Correct. Not necessarily. Two forces with equal magnitudes and opposite direction are not always action-reaction pairs. For forces to be an action-reaction pair are described by Newton's third law, they must act on different objects. Second, two action-reaction pairs cancel each other out. Correct. The reason is that action-reaction forces act on different objects. Newton's third law states that for every action, there is an equal and opposite reaction. These two forces are always equal in magnitude and opposite in direction, but they act on separate entities.
In this summary, I present an overview of Newton's three fundamental laws of motion that form the basis of classical mechanics. Newton's three laws of motion explain how objects move and interact with forces. The first law, the law of inertia. It states that an object remains at rest or in motion unless acted upon by an external force. For example, a book on a table stays still until someone pushes it. The second law, the law of acceleration, states that force equal mass times acceleration, or F equals ma, meaning heavier object require more force to move. For instance, pushing an empty shopping cart is easier than pushing a full. The third law, the law of reaction. It states that for every action, there is an equal and opposite reaction. A common example is when you jump off the boat moves backward as you push off. The laws form the foundation of classical physics.
Thank you for listening.